Hello, now we are going to look at line plots and we'll look at them through this example. So here are the number of siblings a group of students have. So we have each one of these is students' number of siblings. So the first student had no siblings, so they were an only child. Another student had 4 siblings, another had 3 siblings. So each one of these is a student, and the number is the number of siblings that they have, the numbers of brothers or sisters that they have. So what we're going to do is put our numbers of siblings, our different data values, along the bottom. There are going to be our categories, and then how often we see that number of siblings is going to be our frequency, is what we're going to count up along the up and down axis. And the way that we're going to count these is by putting dots in nice, neat rows, in nice, neat lines. So we need to look at how many categories we have to deal with. So we are going from 0 siblings up to 8 siblings. So we need to have our categories going from 0, 1, 2, 3, 4 siblings, 5, 6, 7, 8 siblings. So we need to cover the entire range of possible values in our data set. And if there are numbers missing, we still count everything in between. So we have all of our different categories, all of our different numbers of siblings that we could have based on our data set. And then we are going to start putting a dot for each time we see one of these categories come up, each time one of the students has this number of siblings. So first student has 0 siblings, so we put a dot above 0. And you can see here I'm using the grid to my advantage. All of my graphs are going to be drawn on grid paper, and all of my categories, all of my numbers of siblings are going along the grid lines of my page. So I don't have my 0 sitting out in the middle of a box here. I have it sitting on a line. I have it sitting on a grid line so that I'm able to go up along that line with my dots and keep everything neat and see exactly what my frequency is, because I'll be able to keep the dots an equal spacing apart. And now I'm going to continue, and after each one of these that I do, I'm going to underline it so I don't forget it, that I've done it. And I have 4, 3, put a dot at 3, and 1 and 1 and 1. So 1 and 1 and 1. Them done. And 4 again. And a person has no siblings. And another person has no siblings. And a person has 8 siblings. And a person has 3 and 3. A person has none. We have another 2 3s. And we underline them. We have a 1. We have a 2. All right. So now what we've done is we can now see that we have 4 students. We have 4 dots above 0. So we have 4 only children. We have another 4 who have only 1 sibling. We have only 1 person who has 2 siblings. We have 5 students who have 3 siblings. We have 4 students. We have 2 students who have 4 siblings. We have no one here, and then we have 1 student, 1 dot for 1 student who has 8 siblings. So that's our line plot filled in, and we labeled what we were counting in, our number of siblings, our category, and then we used our dots to count up how often we saw people with that number of siblings. So let's get into answering some questions based on that. So our mode is our most frequently seen number. So mode is the most seen number. And we can see from our graph that there are the most dots at 3. So the mode is 3. The median is the middle number when we order our data from smallest to biggest. So if we wanted to do that, if we just had our list, we'd have to start writing them out. I will actually write out from smallest to biggest just to give an example. So if we didn't have a graph, how would we do the median? We'd have to order our data from smallest to biggest. So here's our data all listed out, our number of siblings all listed out from smallest to biggest. Now this was actually very easy for me to write when I had my table, because I knew I had 4 people who had 0, another 4 who had 1, one person had 2. So the line plot actually orders the data for me automatically, as quite a lot of our graphs do. But I can see now I have my median. So my median, again, when I've ordered from smallest to biggest, as my line plot effectively has done for me, I am able to now get what my middle number is. So median, order from smallest to biggest, and then I have to figure out what my middle number is, what my middle data point is. So I count up all of my numbers, my number of students, and I get a total of 17. So my total number of students is 17. So this is an odd number, so I am actually going to get a specific number as my median. So if I have 17 numbers, that means that I could get a middle number that it would have 8 students less than it, 8 students more than it, and then I'd have the number in the middle. So I have 1, 2, 3, 4, 5, 6, 7, 8, and that's going to be my middle number, and 1, 2, 3, 4, 5, 6, 7, 8. So 2 is the number in the middle. If I had an even number, I'd have to get the average of the 2 middle numbers. But in this case, I have an odd number, so it's just going to be the middle number is my median when I order from smallest to biggest. And again, the line plot automatically gives you the smallest to biggest. So I'd just be able to count up here 1, 2, 3, 4, 5, 6, 7, 8, and then the 9th number is going to be my median because I have 8 numbers above it as well. Now the mean means that we add up our number, all of our numbers, and divide by the number of numbers. So here I can just add up 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 and so on. But I see I have 4 zeros and 4 ones and 1 2 and 5 3s. So the fact that I've grouped these together in my line plot helps me write out my mean faster. So I sum up my numbers, which means add up my numbers, divide by the number of numbers. So I have 17 numbers in total, and I have 4 zeros plus 4 ones plus 1 2 plus 5 3s plus 2 4s plus 1 8. When I add all of them up, I get 37 divided by 17. When I put that in my calculator, I get 2.18 something. Now, that's our mean, and then our range is our smallest number minus our biggest number minus our smallest number. So biggest minus smallest. And that's just 8 minus 0, so our range is 8. Now, are there any outliers or extreme values in our data set? Well, what jumps out to me here is that 8 is a very extreme value in comparison to the rest of this group. And that's what we mean. So in the context of this group, 8 is an unusual number of siblings. So 8 would be an unusual data point. Now, what's the probability of a student having more than 3 siblings? So the probability of a student having more than 3 siblings. So capital P for probability of something being more, the outcome being more than 3. Well, how many people, how many students meet that criteria? Well, all of these people have 3 siblings, so they don't count. So it would only be the people who had 4 and the people who had 8. So 1, 2, 3 people out of a total of 17. So that would be the probability. If I picked one of the students at random, I'd have a 3 out of 17 chance or 3 chances out of 17 of picking someone who had more than 3 siblings.